In this video, we're going to continue looking at our understanding of continuous distributions, also known as probability density functions. But this video, we're going to focus specifically on the measures of center and spread that we could have with these types of functions. So I want to highlight what we mean by center. So measures of center come in three main categories, and we can call these averages, but they are known as mean, median, and mode, and we'll discuss what each means in reference to probability density functions. And then we want to talk about measures of spread. So we have done a little bit of work on variance and standard deviations, but we're also going to explore percentiles and quantiles, which may be new to some of you. All right, so let's have a look at a mean. So when we're talking about a mean, it's a little bit hard to show graphically what we mean by a mean as far as a probability density function is concerned. But when we do discuss a mean, we're using this equation of the integral between the upper and lower limits, x times the function dx. So it's very important that when we're talking about the mean or the expected value, we use the x times the fx component within the integral. That's very crucial. And what we're actually discussing there is we could have some value x here, and this is our expected value, ex. All right, a little hard to show graphically, but we do rely heavily on the formula that I've just presented. When we talk about median, this is a little bit easier to understand graphically. What we're talking about with the median is the middle result. So in terms of percentiles, that would be the 50th percentile. And what it means is that if I split the probability density function down the middle, okay, and I'm going to say that this is my median value here. If I looked at the area on this side of that line, or that value of x, which is our median value, well, I would have 50% of the probabilities in that region, okay? And we represent that as 0.5. Now, we're going to rely heavily on this expression, but it does require further work. So normally when you're working with your CAS, what you're going to do is you're going to set up a solve command, and you're going to set up negative infinity or the lower limit fx dx, and you're going to say equals 0.5, and then you're going to ask it to return to you or find the value of n. That's how we're working about it. The mode is a little bit easier for us to understand. When we talk about the mode, we're really just talking about the max fx result, okay, so the max y result. And in reference to here, can tell from my graph that this would be my mode because that's the maximum result within the domain that I've been given. Here in my second graph, my mode would be located at the very end, which I can have. It doesn't have to be in the middle. Okay. It's the value that's going to return the highest probability or the highest value, F value. And here, that's an interesting graph. We can have two modes. So you can have more than one mode, and it's the result which is most likely to occur. So that's our mode result when we talk about continuous probability distributions. We then get into variance, and there's actually two rules that we could use to find variance. One rule here, which I'm discussing, may not be familiar to you because we don't really cover it in class, but this is a rule that you could use. And the interesting part of this rule is the x minus the mean squared value. I would avoid this rule because you can use it if you got the CAS with you. However, when you don't have the CAS, you can get some really tricky expressions that you need to resolve. So I would avoid this rule. I would opt for our second rule, which we have here. And this is following the traditional, the variance of x is equal to ex squared minus ex all squared. And we would set it up like so. Then we would talk about our standard deviation. A standard deviation is simply the square of the variance x. Just make sure with your standard deviation, you're always taking the positive value with your standard deviation. And then we talk about our percentiles. Now, our percentiles are a little bit like our median. So for our median, I might say that the median is what we call the 50th percentile. And you can see how I set it up with this equation here. But with our percentiles, we don't have to restrict ourselves just to 50th percentile. We could say, okay, well, we want to find, you know, what's the probability of results ranging in the 68th percentiles? So from 0 percentile to 68th percentile. And we would use this type of equation in particular, where we're looking at 0.68, 68th percentile, 0.68. 15th percentile, similar expression, 15th, 15th, 15th percentile, 0.15. And we're just solving on the CAS as such. Interesting thing that probably those of you who don't do general maths are probably going to come across maybe for the first time in methods is this idea of quantiles. So quantiles are just another form of percentiles, but they're specific percentiles. So we say that our quantiles are focused on the 25th percentile, 50th percentile, 75th percentile. What we're saying at those points is that we're being able to break up all of our data into 4 distinct sections. So 0 to 25, 25 to 50, then 50 to 75, and 75 to 100. But really with our quantiles, we want to find Q1, which we call our 25th percentile, and Q3. And we find those quantiles just in the same way that we found our percentiles before. This gives us an interesting measure, which we call our interquartile range. And what the interquartile range is really talking about is talking about the middle 50% of data, okay, or information or probabilities. It's the middle 50% of the data, which gives us a good representation of what's happening with the probabilities or the population. And that's something interesting for us to just consider. Okay, so I'm going to have a look at a problem here. This says let f(x) equal this function, so x over 50 for x between 0 and 10 and 0 elsewhere, and we're saying that fx is a probability density function. So what we want to be able to find from this function is firstly its mean, its median, then its mode, and then we also want, and they're all measures of center, then we also want to have a look at what's its variance, standard deviation, and interquartile range. So if I start focusing on the mean, and I'll just restate the expression just so that we're sure, fx equals x on 50, that's the equation that we're looking at. Our lower and upper limits are 0 and 10, so we just have to have that in mind. If I was working with a CAS, I would actually define that function. I would actually define the domain just in case there's something specific that we need to use. But I would define it on the CAS calculator and then go forward and do my calculations after that. Okay, so if I'm looking at my mean or expected value is equal to the lower to upper limit, 0 to 10, x times the function on 50 dx And a couple of things I could do here. Look, if I was working by hand, I could take 1 out of 50 out of the integral sign, x squared dx, and then mu, or our expected value, I get as 20 on 3, which equals 6.67. Depending on what they're wanting, I would always opt for the exact value if if that's if you're in an exam. Sometimes it's handy to use the approximate, but by all means, try to find the exact value wherever possible. Then we're going to try to find our median. So with our median, what I'm going to say is 0 to some value, which m, which is our median, all over the function x on 50 dx, and we're going to say that that equals 0.5. Now, I am going to have to use my CAS here. Okay, I could try to solve it by hand, but I'm just going to be a little bit smart in the way that I operate. And I'm going to say, I'm going to use a solve function on the CAS, and I'm going to say I'm finding m, and this returns m equaling 7.07. When you're solving these type of functions, you might get multiple answers from the CAS. Just be careful about that. Make sure that your median is going to be within the lower and upper limits. So our lower and upper limits was 0 to 10, 7.07. That fits right into that range. So that's fine for us to keep that as is. Then I'm going to have a look at my mode. So this is considering my max of the function, so my max y value of the function fx. I might want to have a look at the graph to ascertain that. I could sketch the graph and find what it is. There might be a command that I could use. Look, I find my max for this value at x equals 10. That gives us, look, an f10 actually gives us a value of 1 on 5. Question is, which one do we accept as our mode? Remember, we're focusing on the x values with our probability density functions. So our mode is going to be x equals 10, but we'll just say our mode here equals 10. There's not multiple modes with this question, so that's just nice and easy. Then we'll come back up. We'll have a look at our variance. So our variance, I want to note here, we're using this form to find our variance. So I'm going to solve this in parts. So the first part that I'm going to have a look at is what is ex squared. So that's going to be 0 to 10 x squared times fx dx. I'm going to evaluate what that equals. Turns out that that equals a nice round 50. Great. All right. Then I'm going to have a look at ex all squared, because that's the second part of the function at top. I'm just going to note again, I've been given EX as my mean as 20 on 3. So therefore I'm saying 20 on 3 all squared. This gives 409. I'm going to continue working in exact values. That means that my variance of X equals 50 minus 409. This ends up equaling 50 on 9, which in turn I can find an approximate value of 5.56. I'll have the approximate value there, but I do want to highlight again, we want to try to keep the exact values where possible. Then I'm going to focus on my standard deviation, remembering that standard deviation equals the square root of the variance. So this is saying standard deviation is equal to, I'm going to use my exact value, 50 on 9, plug it into my calculator. I find that my standard deviation is 5 root 2 on 3. I'll just get an approximate value to give me some understanding, 2.36. That's my standard deviation. I found a lot of information very quickly, and this is really assisted by the fact of defining the function in the CAS. The last part though is focusing on interquartile range. Don't be worried if you see some abbreviation to it as IQR. That means interquartile range. So what we're first going to focus on is our 25th percentile. Okay, our 25th percentile, I'm going to call that Q1, and that's going to be x on 50 dx equaling 0.25. I'm going to enable my CAS. I'm going to use the solve function, and don't worry about putting subscripts in. Just use Q for this. X on 50 dx equals 0.25. Solving for Q, we therefore get Q1 equaling to 5, which is a nice round value. So when we plug it in the calculator, that's what we're going to get. Then we're going to have a look at our 75th percentile. And our 75th percentile, this is Q3, our third quartile, x over 50 dx, and we're going to say 0.75, 75%, 75th percent, 7.75. We're going to use same function. Now, if you're doing this all on the calculator at the same time, you can simply just use cut and paste. Okay, so you might have cut and paste what you've done for the 25th percentile, but you just changed the result to 0.75. Find Q again. We therefore say Q3 equals, just having a look at the calculator, 8.66. Therefore, we can say that our interquartile range exists between 5 and 8.66. That means that 50% of the data is going to exist between 5 and 8.66. Hope this helps. Keep up the study. All the best.